So I want to welcome you to the review for Chapter 2 for Psych 220. And some of this stuff may seem like it's coming from the first semester, and Test 2 is not a comprehensive final exam, but a lot of what's covered on Test 2 is building off what we learned those first 4 weeks. So I want to make sure that we're kind of covering all that material and also keeping the big picture in mind. So the purpose of this review is not to hit every single thing that might be on the test. I would suggest strongly you review your readings. I would suggest that you look at that study guide and see if you have any questions. I would also say you review the slides and the various lectures as well as the materials from lab. Pretty much anything that's been presented or assigned, whether it was in lab, lecture, or on the syllabus as a reading or an additional resource, is potentially fair game for the test. However, I do hope to hit most of the major concepts that I want to make sure that you understand that you're probably going to be tested on. Now, we've hit this one multiple times, both at the start of the semester, the middle of the semester, and even my last lecture. And that is this concept of what are the assumptions that we start with when we talk about scientific methodology and the scientific method that we use in psychology. And the 3 or 4 big ones here is the concept of determinism, and that's our start point. That's an assumption that we make. It's not necessarily a provable assumption. It is the assumption, however, that all events are meaningful and that causes precede events, that we live in a cause and effect universe, that effects don't just happen without any potential cause, and that when we see an event, we need to find out what those causes were to understand the event and potentially to mitigate or increase or decrease the likelihood of that event occurring. And most of science is based around this concept of what is the outcome or the event, what are the antecedents, which is just a fancy word for causes, and once we've identified those causes, which of those causes can we control to either try to increase or decrease the likelihood of that event based on whether it's a positive or negative event. And that's kind of the core of science, but that is an assumption, and it is determinism, that the universe is deterministic, that you can determine what the causes are for events. The next one is empiricism, that if we live in a deterministic universe, then the best way to learn about that universe is through observation and ideally systematic and rigorous observation. And I've kind of kept using these words, systematic and rigorous, fairly often in this class. I want to just reiterate again that systematic simply means that we're making a set of rules. And that set of rules holds us to a bar, if you will, in how we're doing our observations. And that set of rules also allows us to communicate to others how we did those observations, to where if they question our findings, they could use the same rules to do the same observations. So again, that's the idea of systematic observation. Rigorous observation is more of a measure of how strong or stringent are your rules. We can have a systematic set of rules that are fairly loose and hard to understand, or may not be a very accurate way to observe a various phenomenon. If we have a systematic and rigorous set of observations, the rigorous means that also we really are setting up the very best situation or the best that we can manage situation to make those observations in a meaningful way. So rigor is the strength or the value of our observations, while systematic is that are we setting a set of rules. We talked also about parsimony, the idea that if there are multiple answers to the same question, the simplest is best. And this is not necessarily just trying to find the simplest answer. This is the simplest answer that is still, I'm going to use that word again, rigorous. It should still be providing the most information possible. It should try to be capturing most of the variables or most of the factors that we want to include to really understand a situation that we're observing. And by situation, I can mean everything from your day-to-day life to understanding how an actual physical occurrence happens in the universe. But again, if we have multiple explanations that explain things equally well, always go with the simplest and the easiest to understand. I also referred to in one of the lectures that parsimony is another way to also think about it as utility. How usable is this information? Very complex theories, if necessary, have to be complex theories. But if you can have a very complex theory and a less complex theory that both are fairly the same as far as what they explain and their usability, go with the simpler theory. It's the more usable theory. And finally, this idea, and it's more of just a reminder to us of testability. The theory should be testable and falsifiable. That if we have a theory, which is basically a series of hypotheses or a belief about how the world behaves, and we are going to empirically observe it to test it, those observations should be designed in such a way that they can either find or not find what we think is occurring. In other words, if we set up a study that no matter what the results are, we're still going to conclude that we're right, that's not science. That's not an experiment. That's basically just coming up with logical and philosophical ways to defend your own viewpoint. If you truly are wanting to examine something with empiricism and determinism, you need to make sure that the way that you're observing is done to where you could either, with those observations, support your theory, your hypotheses, or your beliefs, or you will have your theory, your observation, or beliefs challenged or questioned. In other words, they're falsified. They weren't actually the way the world was working on average. So again, if we're looking at the criteria of scientific methodology, we've got these 4 things that we want to make sure that we try to obtain. We want to make sure that whatever we're looking at is observable. Can the responses be tangibly collected in some way? And that doesn't always mean that it's going to be directly observable, but can we come up with a way to infer measurement? So a lot of psychological constructs, a lot of concepts are fairly internal mental events that currently our technology does not directly measure. We can infer it. We can infer it by behaviors. We can refer it by self-report. We can refer it by others' observations. And sometimes we can even infer it by physiological responses, even within the brain. But we still don't know if a particular region of the brain lighting up always means that someone's thinking of an elephant, for example. Now, our technology may catch up to this to where the social sciences are much more observable, more like physical events, like chemistry and physics. However, at the moment, it just is the question, can we observe it in some meaningful way that most people would agree is a good representation of what we're trying to observe? Once we can observe it, can we come up with standardized measurements? So can we come up with a standardized set of rigorous measurements to be able to objectively measure what we're observing in a way that other people, other researchers would agree with and could also use? Again, falsifiable. Can your theory be proven wrong? We want to make sure that we're setting up these observations to where they can either support or refute our beliefs. And finally, that study needs to be repeatable. Can our study be repeated in another situation? Can other people put the same question to test using the same observations? This, if we have all 4 of these very solidly defined and defended through our lit review and through our methodology, we are clearly using scientific methodology. But I also want to stress that sometimes we can't get all 4 of these, but that doesn't necessarily mean that it's not a question worth asking. And it also means that if we can't get all 4 of these, we don't just turn our back on scientific methodology. We still strive to get as close as we can. And that's one of the other goals of science, is to try to set these rules up as the magic bar, if you will, that we want to obtain. But if we can't obtain it, we don't turn our backs on it. We try to get as close as we can. So let's talk a little bit about how we conduct scientific research. We're going to start with a lit review. And again, I really want to just stress that one of the kind of components, this class can often feel somewhat disjointed. We're learning about methodology and theory. We're learning about hypotheses, but at the same time, we're learning about the actual statistical equations and how to interpret statistics. And at the same time, we're learning how to write a paper and to objectively, hopefully, conduct research at some level. But all of this interacts and interconnects. The process of writing a paper is also the process of learning how you build good science on past science. And that's the lit review. It's a review of the scientific literature. In other words, once you have a research question, once you have something that you think you're interested in studying, the first thing you want to do before doing a study is find out what have other people found. What's out there? You want to do this review early, as this review can help to see if your idea has already been tried, to see if your idea has been tried, but there's suggestions of new ways to look at it. It allows you to determine, are I missing any constructs? And remember, constructs are basically psychological phenomenon. They're things that we're interested in. So there are all those things we like to label when we talk about human behavior. It can help us select instruments. We can find out that there's already been a lot of research, for instance, on how to measure a particular construct. So instead of having to come up with our own, we can basically get a pre-existing systematic and rigorous set of rules for observations. That's the instrument. That's the survey that we would use. We can also anticipate common problems that other people have found. So the lit review lets us refine our question. The lit review informs us of previous findings in our question. And the lit review helps us actually kind of mentally work through how is it best to stand on the shoulders of the people that have come before me in this area of research to provide even better research. In other words, we're not having to reinvent the wheel. We're finding out the wheel was already invented, but we want to use that wheel in a new way. And again, the APA paper, by its nature, is also walks through the process of research. And this is the hourglass notion of research. And that's basically that we start with a very broad title and an abstract. So basically starting with theory, broad open-ended questions, focused on past study. And also this is the part of the introduction where we often try to give the big picture of what are we interested in, and also to some degree selling what we're interested in. And then we're going to actually dive into past studies, and we're going to pick those studies hopefully fairly strategically. We're going to look for studies that really made major findings or did a lot of the heavy lifting on ways to observe what we're interested in. So we're going to focus on those past studies, we're going to summarize what is known, and that's going to lead us to our research questions, finally ending up at the end of the introduction with our specific hypotheses. These are testable statements that we're going to put to the test with our hopefully systematic and rigorous rules, our methods. The next section is our methods. That's where we actually walk through who is going to be our participants, how we're going to get them, what their demographics are going to look like, and what are our observations, what are our rigorous and systematic ways of making these observations. Once we actually have that completed, we're going to use those methods to conduct our study, and then we're going to take the results of that findings and write our results section. We're going to analyze the data. Now, we're also going to talk a little bit again about internal and external validity. And internal simply means within the study, external means outside of the study. Validity just means how much do you trust it? How truthful is it? How rigorous is it? So internal validity is about your methods. Do people think that your methods are really getting at your constructs? Do you believe they're reliable? Do you believe that they are a fair test of the research questions? And then once you've conducted your study, are you representing the data that you collected honestly? Are you communicating what the data actually says? And are you using the appropriate statistics? And from that, if you did use those appropriate statistics, that moves us to our discussion section. What are your actual conclusions based on this data? And then based on those conclusions, how do those conclusions fit with previous research, what you covered in your introduction? And finally, generalizing back out to the question or theory in general. How does this study add to what is known? And how is it practically usable? And that's external validity. And external validity is more of a logical argument, but it's also based on how you conducted your methods as far as the sampling. Does your sample represent the population you're trying to generalize back out to? The more that your sample represents that general population, the easier it is to argue for external validity. But the argument for external validity is usually in the discussion section. So again, if we're talking about conducting a study, we're basically talking about the first half of the study. The paper is the introduction section. And it is what you think. It is the theory. It's in the introduction. What are your causal constructs? What parts of human behavior or any events in the physical world do you think are antecedents? In other words, they come before your outcomes. And then what is the relationship between them and your outcome or your effect? What do you think is what's happening in the introduction, but you're also supporting it with what others have thought and what other research has shown. Then you're going to operationalize these ideas into the actual study, your study, and this is the methods and results. So how are you measuring those constructs? How are you observing them? How are you statistically relating them to your observations? And your observations, which represent, again, the effect construct, how are they actually being conducted? And again, are they systematic and rigorous as well? So not only how do you actually bring this from the land of theory into an actual study, but then how do you analyze the data that you gather from that study? So again, just some quick definitions that are always good to keep in mind because we're going to just keep using these throughout this class and the next. An operational definition is the definition of a variable in terms of the activities, operations a researcher uses to measure or manipulate it. So basically, it's how do you move something from the land of the lit review and theory into the land of your actual study. And again, all operational definitions are by their nature a systematic set of rules to make an observation, hopefully in a rigorous way. And a construct is an abstract or general idea inferred from specific instances or observations. So that's a pretty broad concept right there, but basically constructs are the antecedents and the outcomes. They are the causes and effects. But within psychology, both those causes and effects are usually human attitudes and human behaviors, which we're having to infer through various forms of systematic observation, the operational definitions of the constructs. So when we do an operational definition, we're usually trying to change something from a construct into an actual variable. We're wanting to actually get things to vary, and we're wanting those variables to represent constructs. So there is a lot of different ways that we can use systematic observations to gather information about a construct. So for example, if we have an independent variable, so basically an antecedent, a cause, that we think may have effect on a dependent or an outcome, it might be, for example, social economic status. And there's a lot of ways to measure social economic status. We could look at how much family support there is. We could find out how much economic status the person had. We could look at the type of schooling they had. We could look at the type of special tutoring they had. All of these may be factors or different constructs that represent an overall construct, but would involve different observations and different measurements. And then again, our outcome in this case could be academic achievement, which could also be measured in multiple different ways. What we want to consider, though, is as we're creating variables for a study, we do want to be keeping track of which variables do we think are causal agents, antecedents, or independent variables, and those terms are fairly interchangeable, and which variables do we think are outcomes, or dependent variables. And as we're doing that, we also want to ask, especially with independent variables, are they variables that we could ethically manipulate or not? And if they're not manipulatable, that doesn't mean that we necessarily can't still do studies on them, but we're having to use pre-existing information. So I can't ethically break up a family to find out the effect of a single-parent home, but I can compare single-parent homes to dual-parent homes. Now, I'm probably not quite getting the same information that I would if I could ethically force that situation. For example, there may be other factors that predict whether you end up in a single family home, including geographical regions, work styles of the family members, social economic stress. All of those could also be factors that would be comorbid, if you will, with actually one and two parent homes. So for example, if I used pre-existing one-parent and two-parent homes and found that the two-parent homes also had a higher SES, social economic status, more income, less stress due to money, then if I made the conclusion that two-family homes or two-parent homes were better for academic achievement, that might be the causal agent, but it may also be I'm just capturing the impact of social economic status. So when we're looking at independent and dependent variables, recognize that the non-manipulatable versus manipulatable is also getting at, can we do a correlational study? In other words, I found a relationship, but I don't know if it's a causal relationship. It may just be capturing something else. For example, one parent versus two parent versus social economic status. But if I can actually manipulate the variable, I have a lot more ability to talk about causation if I'm the one causing the changes in the independent variable. So if I take a random group of students that basically have equal social economic status, equal gender split, they're all the same age, they're all from the same region, and I randomly assign half of them to get special tutoring and the other half not to get special tutoring, and then I find out those with special tutoring actually do much better on measures of academic achievement, it's hard to come up with an explanation other than the tutoring worked. And again, neither of these are gold standards, but science generally does like studies that can get to causation, can actually rule out other causes, and not just tell us about patterns, but also tell us about this is something that works or doesn't work if we're trying to change human behavior for the better. So again, let's just kind of end up a little bit as we talk about these broad concepts of internal and external validity. So the definitions, internal validity. Can the results of an experiment be attributed to the manipulations of the independent variable? Can we get to cause? Or if we're not looking at a causal study, can we make a strong claim of relationship? So internal validity really asks the questions on every single variable that you're manipulating or measuring. In other words, every operational definition that's in the method section. Are each one of those systematic and rigorous ways to measure that construct, and are they measuring the construct that they claim that they're measuring? And then within the results section, if you find a systematic relationship between variables, were those variables, again, systematic and rigorously measured? And did you use the appropriate statistic? And is the statistic really talking about a situation where we can feel confident that that effect is not due to chance? External validity is simply, can the results of an experiment be generalized from the sample in your study to the population at large? And again, the population is not always the population of the world. What is your population, and is your sample representational of that population? Also, external validity gets a little bit at how realistic was your study. So that is actually one of the failures of some of our more interesting psychological studies, is they were very clearly psychological experiments. They were representing potential real-life events. So for example, think of the Milgram study. So Milgram was actually looking at mass extermination in Nazi Germany. But the way he operationalized it was to bring people in to a research lab where they were having to shock someone with an electric machine as a part of a learning exercise. Now, the results that Milgram found are actually fairly interesting. They really do tell us that people, most people, are willing to conform to very damaging behaviors if they can basically tag that on, I was just following orders. An authority figure told me to do it, therefore it's not my fault, it's their fault. And that's a major finding for psychology. But one of the limitations of the Milgram study is a lot of people asked how many people really thought that they were in a situation where they were actually causing physical harm to another, or were they simply in kind of a high stakes, almost video game-esque state as they went through this experiment. So no research design is immune to the threats of internal external validity, and typically they kind of exist almost on a seesaw. The more you focus on internal validity, generally the more artificial your experiment becomes, because you are trying to control all other possible confounds. And the more you do that, the harder it becomes to generalize to real-world events. The more your study looks just like the real world, the more likely you're not being able to take control of cause, which means you're probably doing more of a correlational or relationship study, which is not an invalid study. It's simply, it can be generalized well, but we're not 100% sure that what we actually captured in our study is capturing everything that we're interested in. And again, I'll go to that example of finding a relationship between 1- and 2-parent homes on academic achievement, while possibly missing a lot of other factors, including just how much economic wealth each family has. So with external validity, that gets us to this idea of how important our sampling and generalizing is, that our sample represents our population. So we want to draw that sample from the population. So we need to know what is the population we are trying to generalize to before we even conduct a study and try to get a sample. And then how successful we are at getting a representational sample is how hard or easy it is going to be to make the argument that what we found in our study would at least represent the population we are interested in. So for example, if your population is working adults in their 30s, but your sample is a sample of freshman college students all 18 years old, that's not necessarily a horrible thing. It may be the only sample you had access to. And most of those 18-year-olds will eventually join the workforce. But it's going to be a lot harder to generalize that back to the population compared to if you manage to actually get a sample of 30-something-year-old workers that were working full-time to be in that same study. And again, just recognize that even if we completely focused on external validity, generalizing from the specific situation of the people studied to any other situation and people not studied, we are still never going to have perfect external validity. So not only are we having to worry about the population, we're also having to worry about the settings, the times, and the places. So settings are the actual methodology of the study. So if I ran this study, but I observed the same constructs, but all the constructs were observed differently, would I find the same findings? People, that's the one we've been talking about, your sample versus the actual population, but also places. So if my study was done in New York City, would I find the same effects in a small rural town in Kansas? If I did my study in Bangladesh, would I find that same findings in Scotland? And finally, even if we did the massive study where we used multiple ways to measure our outcomes, we used populations from all around the world and all the various places, our study is still going to be bound by time. The fact that it was done whenever it was done. If it was done in 2010, would we find those same results across the world 10 years later, 20 years later? Because a lot of psychological constructs and a lot of concepts of what is normal behavior and abnormal behavior are culturally determined and therefore shift over time.